Hello there, and welcome to Chemistry Chapter 1, Lecture 1. We're going to be covering pages 1 through 11 in this Exploring Creation with Chemistry, second edition. And the first problem that we're going to work is on page 10, so you can go ahead and open to page 10 if you would like. You'll need your notes, so your note sheet, pre-printed, and a highlighter. You also need a calculator. Alright, so just going through the notes, this just summarizes the text up through page 10. So what is chemistry? Chemistry is the study of matter. And then matter is anything that has mass. So you want to think, in this class, just think of mass as weight. They're kind of interchangeable. That's not completely true. And if you take physics, you'll see the difference between mass and weight. But in this class, you can think about mass as being the same thing as weight and occupies space. So let's do a little thought experiment and ask a couple of questions. Is air matter? And is light matter? So why don't you think about that a second? Pause the video and then I'll go through the answer. So, is air matter? Well, air is made up of some different elements. Nitrogen, oxygen, a little bit of argon. So air indeed has a weight. And of course it occupies space. So air is matter. Light, however, is just pure energy. Light doesn't, you can't weigh light. All right, so light isn't matter. Light is just pure energy. So just an interesting thought experiment there. So in order to study matter, we must be able to make measurements. Okay, you'll be doing that a lot in your labs this year. And measurements have units. So this chapter is largely about dealing with units. So the first table we come to in the book on page 5 is the physical quantities and their base units. Okay, base units, important term. So the physical quantity for mass, the base unit is gram, the metric unit. So we'll be mostly using metric units in this class. Sometimes we'll use the English units that you may be a little more used to. But the base metric unit is the gram. The base English unit is the slug. You've probably never even heard of that as a unit before. You think of that maybe as the insect. The physical quantity for distance is meter. You've probably heard of meter. It's a little bit more than 3 feet, about 3 1/4 feet. And the base English unit for distance is the foot. For volume, the base metric unit is the liter. So if you think of a 2 liter, maybe a 2 liter soda, so you can think of the size. Half of that would be a liter, so it's a pretty decent amount. And then you're going to be very familiar with a gallon. All right, so there's almost 4 liters to a gallon. If you want to think of how, if you're not sure how to think about how much a liter is. And then for time, the base metric unit and the base English unit are both seconds. So you do need to memorize for the test all of this table. All right, you don't have to memorize table on page 7, table 1.2, only what's in bold. So we've got prefixes that we use in both metric and English units, but prefixes usually this deals with metric units. So you've probably heard of micro, milli, centi, deci, deca, hecta, kilo, and mega. So the 3 that you want to memorize are milli, and milli means 1/1,000. Centi means 1/100. So think of century as 100, so centi is 1/100. And then kilo, it means 1,000. So you need to memorize the bolded items above. All right, so the next thing on your printed notes we're going to talk about the factor label method. And we're going to use this a lot in working our problems today. The factor label method is a way of dealing with units. So let's say you have 1/5 and you want to multiply that by 5/8. So the way maybe you learned to do this in either elementary or middle school math, you just multiply the numerator, the top. 1 times 5 is 5. And then you multiply the denominators. 5 times 8, that would be 40. And then maybe you learn to reduce that to 1/8. All right, but in the factor label method, we really didn't have to go to that much trouble. Another way to think about it is that we can cancel this 5/5, and then all you're left with is 1/8. So why can we cancel 5/5? That's because 5/5 is just equal to 1, and anything multiplied by 1 is just itself. All right, so we're going to use that information to work on your own problem 1.1. So this is on page 10. So we'll take a look at this real quick. It says a student measures the mass of a book to be 12,321 grams. What is the book's mass in kilograms? All right, so we're going to use this factor label method to make this unit conversion. So we're going to start with a big parenthesis. You always want to start 12,321 grams. Start with what you've been given in the problem and put that over 1. That's our first parenthesis. Now, what are we trying to convert to? The problem says, what is the book's mass in kilograms? So I don't want you to put any numbers. We've got a second parenthesis. I just want to put the unit that we're going to on top. Kilograms on top. And the unit that we're converting from on bottom. So that way, that unit we're converting from, it's grams over grams. And just like that 5/5, that's the same thing as 1. So we can cancel those out. Now, you do have to have a little knowledge here. A kilogram is actually much bigger than a gram, right? In fact, there's 1,000 grams in a kilogram. You want to put a 1 beside the larger of the two units. So we put a 1 beside kilogram. And then how many grams are in a kilogram? There's 1,000 grams in a kilogram. So we're going to put that on bottom. So the grams cancel out. And in your calculator, if it's on bottom, all right, if it's on bottom, that means you divide. So we take the 12,321, that's on top, we divide by 1,000. And I don't know if you can see that. My calculator's dusty. All right, it's 12.321. So 12.321, and the unit is kilograms. All right, that's what's left. The grams canceled out. So let's circle our answer there. All right, there's your start to chemistry. A lot of math in chemistry. So let's do on your own 1.2 on page 10. So you've got room on your notes to write all this in. So 1.2 says, if a glass contains 0.121 liters of milk, what is the volume of milk in milliliters? All right, we always want to start with what we've been given. So we've been given 0.121 liters. There's nothing else you could really start this problem with because that's what they gave you. We want to convert this to milliliters. So what we want to convert to, we put on top and then the unit we want to convert from, that's the unit we want to get rid of, we put on bottom. All right, liters. So if you're not sure which unit you're getting rid of, just go back up one and go to the left, and that's what we're getting rid of. Now, which is bigger, a liter or a milliliter? All right, well, a milliliter is just a tiny little amount. In fact, if you're in the lab, you can get a graduated cylinder out, take a look at it, and one of those marks is a milliliter, so a tiny amount. A liter is quite a bit. So you put the 1 by the bigger one, which is the liter. How many milliliters are in a liter? Well, it's 1,000. A milli means 1 over 1,000. There's 1,000 milliliters in a liter. All right, so if the 1,000 is on top, that means we multiply. Okay, so we'd start with 0.121, and we multiply that by 1,000. And you might not even need to use your calculator for this, but you'd get 121 liters. You could just move the decimal 3 places to the right. 121, milliliters. We got to get the unit right. So you get the unit wrong, it counts off on the test. So 121. All right, I think I've got room on my whiteboard to work one more problem. Let's do on your own 1.3. So that's also on page 10. And reading through that, we have on a professional basketball court, the distance from the three-point line to the basket is 640.08 centimeters. What is this distance in meters? All right, so I want you to pause the video and based on these two examples, try to do this one on your own, and then you can check it in a minute when you hit play. All right, go ahead and do that. All right, welcome back. So we're going to start with what we've been given, 640.08 centimeters. Want to put that over 1, and we want to convert that, according to the book, to meters. So meters is the unit we're going to put on top, and we're trying to cancel out centimeters, that one right there. Now, what's bigger, a meter or a centimeter? All right, the meter's bigger. How many centimeters are in a meter? Well, centi means, remember, 1 over 100. So that means there's 100 centimeters in a meter. So a centimeter is less than half an inch. So pretty small distance. So if it's on bottom, do you divide or do you multiply? All right, you divide. So in your calculator, of course hopefully you can do this in your head, but you'd have 640.08 divided by 100, and that is 6.4008. All right, and let's make sure to put the unit, the new unit. We know that our centimeters canceled out, and now we are in meters. All right, great. We are moving right along. A lot of math and chemistry. You're going to get really good at math if you're not already during this year. All right, let's take a look at, and we're going to do some English and metric conversion. So let's take a look at, in fact, let's go through that table on the notes real quick. So we're right here, and there are a couple of these you do need to memorize. The first is 1 inch is equal to 2.54 centimeters. So you need to memorize that. And then mass, the slug in kilogram, you'll need to use this in the problem, but you don't have to memorize that. And volume, a gallon is equal to 3.78 liters. So on the test, you would need to have those two relationships memorized. Okay, so let's do 1.4. page 11 says, how many slugs are there in 123.5 kilograms? Okay. Well, we always want to start with what we've been given. 123.5 kilograms. Put it over 1. All right, you've made a start. Even if you weren't sure where you were going to go, you've made a start here. Now, we're going to put the units that we're converting to, and we're converting to slugs. So let's go ahead and put slugs on top. And the unit that you are canceling out, which is kilograms, we're going to put that on bottom. Now, what's bigger, a slug or a kilogram? Well, let's look at the number. It says 1 slug is equal to 14.59 kilograms. So a slug is a lot bigger than a kilogram. It's 14.59 times bigger than a kilogram. So the 1 is going to go by slugs. And then from the table, we'd have 14.59 kilograms in a slug. So before, are we going to multiply or divide? All right, we're going to take 123.5 and divide, since it's on bottom, 14.59. And we'd have 8.46 slugs. Now, we'll talk about how many places to round it to on a later lecture, but for now, 2 places is just fine. You know, our kilograms cancel out, and we know we're in slugs. All right, this first, I always like to do the first lecture of the year, make it really short. So this is our last problem for this lecture. So on your own, 1.5 on page 11, it says, if an object occupies 3.2 gallons of space, how many liters of space does it occupy? All right, what are we going to start with? 3.2 gallons. Nothing else we could start with. I'm going to put that over 1 because nothing else was given in the problem. How many liters? So let's put liters on top. What am I going to put on bottom here? All right, what I want to cancel out, what I'm going from, which is gallons. Okay, what's bigger, a gallon or a liter? Now you may just know in your life that a liter is definitely smaller than a gallon. But 1 gallon is 3.78 liters. So it takes almost 4 liters to make up a single gallon. The 1 goes by the bigger one. A gallon is bigger than a liter. There's 3.78 liters to a gallon. So it's on top. We're going to multiply 3.2 times 3.78. And that is 12.096, or 12.1 if you want. I haven't gone over the rounding part yet. Liters. So gallons cancel, and we've got liters. So the homework, if your teacher assigns you homework here, you may end up with your teacher may go further than this and add a few problems, but if your teacher stops here through on your own 1.5, the homework assignment that goes with this is on page 35. Do the review questions 1 through 5. And then on the next page, page 36, the practice problems, you can do 1 through 3. All right, and then you will need to read, in order to do this, read pages, since we went over them pretty quick, read pages 1 through 11 in order to answer all of the review questions. Or you can look at your notes, and that might answer a few of them as well. All right, that does it for your first lecture in chemistry, and I will talk to you next time.